Hello students, today we start with the chapter wave. Okay, what is the chapter? Wave. So first of all students, what is the definition of wave? Wave means what? Propagation of disturbance in a medium is known as wave. Okay, what is the definition of wave? Propagation of disturbance in a medium is known as wave. Propagation of what? Propagation of disturbance in a medium is known as wave. Okay, so what is the meaning by wave? Wave is what? Propagation of disturbance in a medium is known as wave. Suppose if we between two fixed end, if string is connected, suppose this is the two rigid support, between two rigid support string is connected. Now students, if disturbance is there, now we apply the force, then see wave is produced. This is the what? Disturbance in a medium. Propagation of a disturbance in a medium is known as wave. Chalo, now students, basically there are three types of waves. Basically there are three types of waves. Basically there are three types of wave. First, mechanical waves. Second, EM waves, electromagnetic waves. And third is matter wave. Okay, EM waves, and third is matter wave. Chalo, so first students, we understood what is the meaning by mechanical waves. Chalo, suppose see students, for propagation of wave, if medium is required, then the such type of wave is known as mechanical waves. Okay, for propagation of wave, if medium is required, then it is known as mechanical waves. Any type of medium is required, then the waves are known as mechanical waves. So what is the definition of mechanical waves, students? If medium is required, for propagation of wave, then it is known as mechanical waves. Okay, medium, for propagation medium is required, then is known as mechanical waves. What are the example? See, what is the example? Waves on a string What is the first example? Waves on a string. What is the second example? Waves in water. જો સ્ટુડન્ટ્સ અહીંયા જે વેવ ક્રિએટ થાય છે for that what is the medium? String is medium. Waves create in a water, then in that case what is the medium? Water. So if for propagation medium is required, then it is known as mechanical waves. Okay, and students, two types of mechanical waves. Two types of mechanical waves. What is the first type? Two types of mechanical waves. What is the first? Transverse wave and longitudinal wave. Okay, that will study in detail in this chapter. Okay, પહેલાં આપણે ઓવરવ્યૂ લઈ લઈએ all the three waves નો, પછી આ ડિટેલમાં સ્ટડી કરી. Okay, see students, in this chapter we will discuss all about mechanical waves, means transverse and longitudinal wave. And these two, EM waves and matter waves, you study in a standard 12. Okay, in 11th standard chapter wave we study what? Mechanical waves, and there are the two types of mechanical waves, transverse and longitudinal. And what is the meaning by mechanical waves? For propagation of mechanical waves medium is required, then it is known as mechanical wave. Okay, if medium is required, then it is known as mechanical wave. Chalo, so now students we discuss second type. Now we discuss second type, that is what? EM waves. EM wave is also known as non-mechanical waves. Okay, chalo, so students, in the case of propagation of EM waves medium is not required. Okay, either its medium is there or not there, EM waves can propagate. So in the case of propagation of EM waves medium is not required. For propagation of EM wave for propagation of EM wave medium is not required at all. Okay, that we study. Okay, medium hoy to bhi chale, no hoy to bhi chale. EM waves can passing through the vacuum also. Okay, and what is the speed of EM waves in a vacuum? That is the same as speed of light. Okay, and what are the types of EM waves? As we know students, radio, microwave, all are the what? EM waves. That we'll study in a detail students. તમે ભણી ગયા છો chapter number 8 12th standard. Okay, EM waves. ચલો, now next students, it means for propagation of EM waves medium hoy to bhi chale, no hoy to bhi chale, they can propagate. Okay, chalo, so now next matter waves. Now this is matter wave we also study in a chapter number 11, de Broglie wavelength. Matter waves means more due to the motion of a particles like electron, proton, neutron, wave pattern is formed. This is known as matter waves. Okay, due to motion of electron, proton, wave pattern is formed, and this is known as matter waves, and that de Broglie wavelength, and the wavelength is known as de Broglie wavelength. That also we study in a 11th chapter. Okay, हमने करी लियो है dual nature of radiation of matter. We discuss 5 types of different formula of de Broglie wavelength. Lambda is equal to h by p, lambda is equal to h by mv, h by under root 2 mk, under root 2 mqv, and for gas particle h upon under root 3 mkbt. That we all the discuss, right? So now next students we discuss matter waves. That is the matter waves we'll study. 3 types of waves, categories of waves: mechanical waves, EM waves, and matter waves. EM waves and matter waves in a standard 12, and mechanical waves in a 11th standard. Okay, chalo. So now we detail study. See, 2 types of mechanical waves: transverse and longitudinal. First we study transverse, after that longitudinal wave. So now see students, 2 types of mechanical waves. First is transverse wave and then longitudinal. Chalo. So what is the meaning by transverse wave, students? So see, in case of transverse wave, oscillation of particle is perpendicular to the direction of propagation. Okay, so in transverse wave, in transverse wave, oscillation of particle is perpendicular to direction of propagation. And see, what are the examples, students? First example, waves on a string. What is the first example? Waves on a string. See students, suppose between 2 and we connect between 2 rigid and string is connected. Now see, wave is produced. So કેવી રીતના oscillate થાય students? In like that, in that manner string is oscillate, means particle are oscillating. So this is the oscillation of particle, and see, this is the direction of propagation, this is the direction of propagation. So this is the direction of propagation. Horizontal is what? Direction of propagation, and vertical is what? Oscillation of particles. So oscillation of particle is perpendicular to direction of propagation. So students, waves on a string is an example of transverse wave. EM waves are also transverse wave. Okay, EM waves are also transverse wave. See students, તમે કહેશો કે સર, but in the case of EM waves medium is not required. એટલે એવું નથી કે મીડિયમ ઇઝ નોટ રિક્વાયર્ડ, મતલબ મીડિયમ હોય તો બી પ્રોપોગેટ થઈ જાય, ના હોય તો બી પ્રોપોગેટ થઈ જાય. ઓકે, चलो, so EM waves are also transverse wave. See students, याद करो, in the case of EM waves, if suppose this is the direction of propagation, then if electric field is in y direction, then magnetic field is in z direction. Okay, so oscillation of electric and magnetic field are perpendicular to what? X-axis. So EM waves are also transverse wave. Okay, in the case of transverse wave, oscillation of particles are perpendicular to the direction of propagation. Now next students, that speed of wave on a string. Okay, speed of wave on a string or wire depends on speed of wave on a string depends on tension in a string and linear mass density of a string. Okay, speed of wave on a string depends on tension in a string and linear mass density of a string. Clear? So speed of wave on a string is what? Depends on what? Tension in a string and linear mass density of a string. So students, linear mass density means mu. Okay, mu means what? Linear mass density means what? Mass per unit length. Okay, what is the meaning by linear mass density? Mass per unit length. Okay, so speed of wave on a string depends on tension in a string and linear mass density. Linear mass density means mass per unit length. Chalo. So what is the speed formula students? See, speed of wave on a string is given by under root T by mu. Okay, speed of wave on a string is given by under root T by mu, where T is what? Tension in a string and mu is what? Linear mass density. What is mu? Linear mass density, and linear mass density means mass per unit length. Okay, and see students, during the propagation of transverse wave, crest and trough are formed. Crest means upper side maximum displacement is crest and lower side maximum displacement is trough. So crest, trough are formed during the propagation of EM waves. Crest, trough, crest, trough, crest, trough em chaltu hoy. Chalo, so that is the transverse wave. Okay, oscillation of particles are perpendicular to the direction of propagation. Okay, this is the direction of propagation. Horizontal is the direction of propagation and oscillations of particles are perpendicular to the direction of propagation. Then such type of waves are known as transverse wave. So now students, we discuss numericals MCQ based on this. Okay, see students, what is the question? A string of mass. What is the mass of string? 2.5 kg. A string of mass 2.5 kg is under a tension of 200 Newton. The length of the stretched string, suppose this is the two rigid support, and between two rigid support string is connected. What is the length of the string? Length of the string is 20 meter. So what is the length of string? 20 meter. If the transverse jerk is struck at one end, means disturbance is created at one end, then waves are produced. Chalo, so see, we want to find what? The disturbance will reach the other end in which second? Okay, so we want to find time taken by wave to reach at other end. Okay, so we want to find what? Find time taken by wave to reach at other end. Chalo, so we want to find time taken by wave to reach at what? At other end. Chalo, so we want to find time. Okay, see, what is the distance traveled by wave? It is what? Distance traveled by of wave is what? Same as length of string. So we know the distance. Now speed is equal to distance by time. So if you want to find time, then first find speed. So what is the speed of a wave? So speed of wave on a string is given by under root T by mu. But see students, mu is not given. So mu is what? Mass per unit length. So L is in multiply. So TL by M. So what is the tension in a string? 200. What is the length? 20. And what is the mass? 2.5. Sure. So what is the answer now? 200 into 20 divided by 2.5. So 1600 and its root. So 40 meter per second. Okay, what is the speed? 40 meter per second. Now we want to find time. So speed is equal to distance by time. And what is the distance? Length of a string. What is the distance traveled by wave? That is equivalent to what? Length of the string. So time is equal to L by V. Length is 20, speed is 40, 1 by 2. So what is the time taken? 0.5 second. Okay, what is the time taken? 0.5 second. So now next question. So now see next question. Uniform rope of length L and mass M1 hangs vertically from a rigid support. ठीक है, चलो then what? Suppose say this is the what? This is the rope, students. This is heavy rope, okay? And what is its mass? M1. And see, then next is what? A block of mass M2 is attached to the free end of the rod. Here we attach M2. Transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. At the lower end wavelength of wave is lambda 1, and at the top wavelength of wave is lambda 2. We want to find ratio of lambda 2 by lambda 1, and see what are the options. M1 plus M2 by M1, M2 by M1, then what is option C? So see students, what is the question? This is a very uniform rope, but heavy rope. What is its mass? M1, hangs vertically from a rigid support. Okay, and then we connect with the free end of the rope. We connect what? Rigid. We connect at the free end. We connect block of mass M2. So now at lower end wavelength of wave is lambda 1, and at the top wavelength of wave is lambda 2. Now see students, it is the rope, and see throughout the rope wavelength of wave is different. Why? Because this rope is heavy, students. Okay, so if rope is heavy, then tension is not same at all points of rope. Okay, if rope is heavy, then tension is not same at all points of rope. અત્યાર સુધી તમે શું જોતા? લાઇટ સ્ટ્રિંગ. એવું જ ક્વેશ્ચન જ્યારે ચાલુ થાય ને, જોજો એમાં શું આવતું? લાઇટ સ્ટ્રિંગ. ચેપ્ટર નંબર 5 માં જોજો, લોઝ ઓફ મોશનમાં લાઇટ સ્ટ્રિંગ. So light string means it is a mass of string is very low, so then we consider tension is same. But now in that case tension is not same at all points of rope, because rope is heavy. It is some finite mass M1. So write one note, students. Write one note. If rope or string is heavy, then tension is not same at all points of rope, then tension is not same at all points of rope. Why? Because rope is heavy, right? So tension is not same at all points of rope. So here rope having a finite mass, so rope is heavy, so tension is not same. That's why if tension is not same, then V is equal to under root T by mu. Tension not same, then speed not same. If speed is not same, then wavelength is not same. Now how to find this wavelength, students? First see. So first of all, students, find tension at lower and upper end. So at lower end, what is the tension? See, tension is in opposite direction of weight. Okay, so at lower end, what is the tension? M2G. As we know, okay, here rope is heavy, so tension is not same at all points. So first find tension. Now students, what is the tension at upper points? See students, at upper end હોય તો રોપને પોતાનું પણ વેઇટ એક્ટ થાય. લોઅર એન્ડમાં ખાલી એને અહીંયા બ્લોક હોય તો બ્લોકનું જ વેઇટ આવશે. બટ એટ અપર એન્ડ રોપ એક્સપિરિયન્સ ઇઝ ઓવન વેઇટ ઓલ્સો. ઓકે, એટ અપર એન્ડ રોપ એક્સપિરિયન્સ ઇટ્સ ઓવન વેઇટ ઓલ્સો, એટલે પોતાનો વેઇટ આવી જશે. વોટ ઇઝ ઇટ્સ વેઇટ? M1G. બિકોઝ ક્યાં તમે મેઝર કરો છો? અપર એન્ડ. સો અપર એન્ડમાં એનો પોતાનો વેઇટ એડ કરવાનો. સો both are downward, M1G and M2G. M1G is what? Weight of rope, and M2G is what? Weight of block. Both are act on a string, on a rope. So M1G plus M2G. Clear students? So at upper end we measure both mass of block, weight of block as well as weight of rope. Chalo. So we measure the tension at lower and upper end. Now see, what is the speed? Under root T by mu. Mu is same. Why? Because uniform rope. So linear mass density is same. Chalo. Now speed. See students, as we know, frequency is equal to C by lambda. But here not free space, it is a medium rope. So we write here V. So V is equals to nu lambda. Nu is a frequency. As we know students, frequency is a property of source. Frequency does not depend on a medium. So here frequency remains same. Wavelength is a property of medium. So wavelength is proportional to root T. Okay, so wavelength is proportional to what? Root T. Chalo. So what is we want to find lambda 2 by lambda 1. Lambda 2 is what? Lambda 2 is what? Wavelength at top. Okay, so આપણે અહીંયા ચેન્જ કરી દઈએ. Lower end 1, upper end 2. Okay, lower end 1, upper end 2. Chalo. So lambda 2 means wavelength of wave at upper end. Lambda 1 wavelength of wave at lower end. T2 tension at upper end, tension at lower end. Chalo, so what is the answer? Lambda 2 by lambda 1. What is the answer of T2? G M1 plus M2. What is the answer of lambda 1? What is the answer of T1? M2G. GG cancel. So lambda 2 by lambda 1 is equal to, chalo, clear students? Chalo, okay students, so now we discuss second type of wave, that is longitudinal wave. Chalo, so see students, longitudinal wave are what? So what is the definition? So in the case of longitudinal wave, oscillation of particles are along the medium. Okay, along the medium. In case of transverse wave, oscillation are perpendicular to medium. Here oscillations are along the medium. In longitudinal wave, oscillations of particles in longitudinal wave, oscillations of particles are along the medium, means with the medium EM waves are in the case of longitudinal waves, oscillations of particles are along the medium, means with the medium or with the propagation are along the direction of so in longitudinal wave, oscillation of particles are along the direction of propagation, and see in the case of transverse wave, oscillations are perpendicular to direction of propagation, and here along the direction of propagation. Along the direction means what? With the direction of propagation. See, what are the examples? So see, example is what? Sound wave. Sound wave is an example of longitudinal wave. See, sound wave, in the case of sound wave, oscillations are what? Along the medium, along the air. चलो एयर ની સાથે જતા જાય, સાઉન્ડ વેવ આગળ આગળ જતા જ જશે with the along the what? direction of propagation. Okay, જે તમે બોલો છો સાઉન્ડ વેવ, so એ propagate ક્યાં થશે? Along the direction. So oscillations of particles are along the direction of propagation. And what are the examples? Sound wave. See students, during the propagation of sound wave, during propagation of sound wave, compression and during propagation of sound wave, compression and rarefaction are formed. Okay, now see what is the meaning by compression and rarefaction. Suppose this is the speaker, students. Okay, suppose this is a speaker. Now throughout the speaker, from this speaker, sound waves are coming. So see, during that propagation, compression and rarefaction are formed. During the compression, air particles are moving close to each other. Air particles are moving close to each other. Okay, so this is the compression, and during rarefaction, air particles are moving away from each other. Okay, between two compression there is one rarefaction. In rarefaction, air particles are moving away from each other. Again, during compression, air particles are moving towards each other. During rarefaction, moving away from each other. So this is the compression and rarefaction. Okay, so students, during the propagation of transverse wave, crest and trough are formed. During the propagation of longitudinal wave, sound wave, compression and rarefaction are formed. During the compression, air particles are moving towards each other, and during the rarefaction, air particles are moving away from each other. And between two compression, there is one rarefaction. Again, rarefaction, then compression, rarefaction, then compression. So in this manner, sound waves can propagate. Okay, and they in the case of sound wave, oscillations of particles are along the medium. Chalo, so now see students, speed of sound wave, speed of longitudinal wave depends on speed of sound wave depends on speed of sound waves depends on modulus of elasticity and density of medium. Okay, it depends on what? Modulus of elasticity and density of medium. Now what is the modulus of elasticity, students? Modulus of elasticity means stress by strain. Okay, what is the meaning by modulus of that way students we study in chapter number 9, but ત્યાં તમારે use આવશે એટલે તમને થોડું recall કરાવી દઉં. So modulus of elasticity means stress by strain. And what is stress, students? Stress means restoring force by area. And what is the strain? Change in dimension by change in dimension by change in by original dimension. Okay, suppose in a case of longitudinal strain, length is changed. So what is the longitudinal strain? Delta L by L. In volume strain, volume is changed. So what is volume strain? Delta V by V. Chalo. So now what is the speed of sound wave? Depends on what? Modulus of elasticity. How many types of modulus of elasticity? 3. Young modulus, bulk modulus, and modulus of rigidity, shear modulus. Okay, how many first? What is the meaning by modulus of elasticity? Stress by strain. Then how many types of modulus of elasticity? 3. Young modulus, bulk modulus, and shear modulus. Right? Chalo. So what is the speed of sound wave? V is equals to E by rho, where rho is what? Density of medium. Now if medium is solid, for solid medium, what is the speed of sound wave? What is the elasticity modulus here we used? Young modulus. Okay, because young modulus is for solid. Young modulus means what? Y means, आपण याद रखજો स्टूडेंट, આની પહેલા આપણે વાત થઈ હતી. In the case of oscillation, young modulus means longitudinal stress by longitudinal strain. Okay, now longitudinal stress means F by A. As we know, stress means what? Restoring force per unit area. And what is the strain? Change in dimension by original dimension. Change in dimensional by original dimension. So in case of longitudinal strain, length is changed. So we write delta L by L. So then for fluid medium, if medium is fluid, okay, if medium is fluid, then we write what? B by rho, where B is what, students? Bulk modulus. And bulk modulus means what? Volume stress by volume strain. Bulk modulus means what? Volume stress by volume strain. So now what is the meaning by volume stress, students? What is the meaning by volume stress? Again, it is a force by area, but and volume strain means what? Delta V by V. But students, in which case volume is changed? See, volume is changed when force is applied to each and every part of a body. If force is applied to each and every part of the body, then and then volume of body is changed. Okay, suppose તમારે balloon છે ને blow કરવો છે ને volume increase કરવું છે, then this is the done by the air. જેવી air inside માં જશે balloon માં, so volume of balloon is increased. Why? Because air is a one type of fluid, and due to that air, force is exerted at each and every part of the balloon, so that's why volume of balloon is increased. So this is done by the air, means fluid. So this is possible in case of fluid. Okay, so first of all, in the case of volume, in the case of bulk modulus, volume is changed, and in which case volume is changed? If force is applied to each and every part of the body. If force is applied to each and every part of the body, then and then volume of body is changed, and this is possible only in fluid. Okay, what is our example? When air is enter in a balloon, then air exert force on each and every part of the balloon, and volume of balloon is increased. Kariye chhe ne, blow kariye chhe ne balloon ne. So this is the example. Balloon is a example of volume expansion, and this is done by the air, means by the fluid. So volume is changed by the fluid, and so for fluid students, force by area is known as, okay, fluid hoy, fluid માં force by area ને શું કહેવાય? Pressure. Okay, ચલો. So bulk modulus means P by delta V by V, and young modulus means what? F by A delta L by A. Chalo, now see one question, students. The volumetric strain of a water at a pressure of, now water is a fluid. The volumetric strain of a water at a pressure of 10 raised to 5. What is the pressure? 10 raised to 5. And what is the volume strain? Volume strain means delta V by V. What is the volume strain? 5 into 10 raised to minus 5. Determine the speed of sound in water. Find speed of sound in water. And for water, what is the bulk modulus? What is the density of water that we know? 1000. So now students, here medium is what? Water means fluid. So if medium is fluid, then what is the formula of speed? Under root B by rho. Then what is the formula of speed? Under root B by rho. So what is the formula of speed? Under root B by rho. Why we use B by rho? Because medium is water. So we used B by rho. But bulk modulus is not given. So what is the formula for bulk modulus? C P upon delta V by V. Delta V by V is known as strain, volume strain. P is pressure. What is the pressure? 10 raised to 5. 1 by 5 means 0.2. Minus 5, so plus 5, so 10 raised to 10, so 2 into 10 raised to 5 Newton per meter square. So 2 into 10 raised to 9, what is the density? 1000. So 2 into 10 raised to 6, what is the root of 2? 1.41. into 10 raised to 3 meter per second. Clear? So this is the one speed of sound wave in water. That is what? 1.41 into 10 raised to 3 meter per second. Sure. Okay, students. So this is the what? Speed of sound wave in water. Chalo. Now in next lecture, students, we discuss the combined relation between transverse wave, combined numericals of transverse and longitudinal wave. Okay.